Today we're going to learn how to describe different transformations of polynomials. And your goal today is to use the proper mathematical language to describe how a graph is changed when numbers are multiplied, added, subtracted to whatever function I give you to start off with. So a couple of vocabulary, or one major vocabulary, is the parent function. So you guys are going to be seeing a lot of parent functions. And to show you some examples of parent functions, one parent function that you guys have seen multiple times would be x. And another parent function that you guys have seen a few times is x squared. Now the ones that you may not have seen as much are going to be obviously the x cubed, x to the fourth, x to the fifth, and so on and so on and so on. So all of these are parent functions because they all have a 1 in front, and they don't have any numbers in parentheses before the exponents, and they don't have any numbers here after the exponents. Before I can describe what a transformation is, I should probably look at the different types that we might see. So when we have a parent function, f of x, we have a number in front of it that causes it to change. So this number you guys have seen in your quadratics. It's where it makes a quadratic go from looking like a U-shaped graph to an upside down U-shaped graph. Okay? Or it makes a beautiful graph like this become very skinny instead, or vice versa. So we have some special terms for this. Let's first talk about what happens when this value is positive or negative. So if it's positive, it doesn't really change much. But if it's negative, then we call it a reflection over the x-axis. Now there's two other things that the a also does. It's very special because it's a vertical stretch and a vertical shrink. So what it can do, it can make our graph look very narrow, as if somebody has taken the ends of the graphs and are pulling on it as tight as they can. Or it becomes very wide, as if someone is pushing down on the ends of the graph and pushing the sides out. So if I have a rubber band, as you can see here in this picture, see how relaxed it is? So imagine like this is just a normal rubber band. There's no vertical stretch or shrink on it. But if I was to suddenly pull on it, notice that these sides here, the width, suddenly got more narrow. So a vertical stretch literally means you're pulling the ends of the graph up so tight that it gets skinnier and skinnier, it becomes more narrow. Now if I was to reverse that action and push it back down, it would once again become wide like this picture. So a vertical shrink would make the ends wider. So we say that a vertical stretch happens whenever your a value is greater than 1. And if it is less than 1, so between 0 and 1, like a 1/2, 3/4, 0.3 repeating, or etc., then it becomes a vertical shrink. So these are the three different possibilities of what your a value could do. Now, I will tell you that these two will never be within the same problem. It will either be a vertical stretch or it will be a vertical shrink, but it won't be both. Now it could have a reflection and a vertical stretch, or a reflection and a vertical shrink. But these two will never be on the same problem at once. Now the other instance that we have involves a value here. And we call this the h value. And it's the h value because it affects the graph horizontally. Now as a reminder, if you're talking about horizontal, that means it's either to the left or to the right. It is not up or down. So please never ever ever say that it would be horizontally up or horizontally down. Horizontal is either left or right. So we have some tricky things here because our h value has a minus in front. So that means that whatever number is here, we actually have to take the opposite of what's there. Okay, so for example, if I had x plus 3 there, then my h would actually be a negative 3. And that's because to get a negative to become a positive, I would need to have another negative there. Now I'll go into more detail when we get to our examples. So we say if h is greater than 0, it's a horizontal shift to the right. And if your h value ends up being less than 0, there's a horizontal shift to the left. Now there is one other small thing that could happen, and we don't really have a letter for this. But before I move on to the letter on the outside of the parentheses, I do want to talk about what happens if this value ends up being a negative. Okay? So I'm going to write here as a little note, if there is a negative in the parentheses and in front of the x, then it is a reflection over the y-axis. Now I don't see this very often, but it does occasionally pop up. So I always like to point it out before really moving on. Alright, our last letter to worry about is the value of k. Now the value of k shifts our graph vertically up or vertically down. And it's very straightforward. If your k is positive, it's a vertical shift up. And if your k is negative, then it's a vertical shift down. Okay, so these are all the different transformations that could occur, and it's using the proper mathematical language. Now, the only thing that I don't have are obviously numbers after these little characteristics, these transformations. So let's get into an example, and I'll show you guys how to write this. So for example 1, we're going to describe the transformation using proper mathematical vocabulary given the parent function. So the parent function in this case is f of x, and it's x to the 7th power. Now we really don't care what degree it is, we only care what transformations occurred. So instead of giving you guys the messy formula right here, we're just going to give you the numbers that take place on the f of x. Now, it doesn't matter what order you go in. I personally like to start on the left and work my way to the right. So the first thing I'm going to look at is this negative. So remember I said that if you had a negative in the front, then it means that it's a reflection. So I would write that we have a reflection over the x-axis. And that would describe what this negative is doing to my function. Now the next part is the 3. Since 3 is greater than 1, I know I have a vertical stretch. So we write a vertical stretch of 3. And now we've taken care of our a value. Alright, the next letter I talked about, or the next was talking about this little negative here. And there isn't anything there, so I can skip over it and move to the 4. Now the issue here is that this 4 isn't actually a positive. It is actually a negative. And this is because in our formula over here, h has a negative sign up front, which means take the opposite of h. So in this case, my h value is actually a negative 4, not a positive 4. So since my h is negative, I know that this is a horizontal shift to the left. Now, since we're going to the left, that word is already taking care of the negative. So I don't say that it horizontally shifts to the left negative 4. We just say left 4. So this left is taking care of the negative value. Alright, so now we've taken care of the 4, we're going to move on to the 2. So this 2 was the k value on the outside. And I believe I used purple, so I will stick to my color coding for you guys. Alright, so since this is on the outside, it's really straightforward. It's a positive number, and it's as is, so I just say that it's a vertical shift. Since it's positive, it goes up 2. And now I have described the transformation properly for this parent function. Alright, example 2. So once again, I am going to start on the left and work my way to the right. So as you see, we have a fraction here. So I need to make sure that this fraction is actually less than 1. And it turns out that 1/2 is 0.5. That is obviously less than 1. But I don't have a negative this time, so I don't need to worry about writing the reflection. So on the problem that we had before, we had this negative, which made us write this one first. But now I don't need that. There's obviously no negative there. So all I need to write is that we have a vertical shrink 1/2. And then we go to the next one. So this right here, remember I said we take the opposite. So our h is actually a positive 2, not a negative 2. So since our h is positive, we have a horizontal shift to the right. And we'll write right 2. And then our last one is this negative 1. And the negative 1 is, well, just a negative 1. Our k is a negative 1. So it's a vertical shift down 1. Alright, the other types of problems that you guys are going to have is when you have to describe the transformation based on given graphs. So on your homework, the parent function is bolded. But in this example, our parent function, the function we started with, is going to be red. So we know that all of our parent functions always start at the origin. So I'm going to make this a little bit bigger just so that we can see it. Oops. There we go. Alright, so here you can see that it's at the origin. We have a root there. So what I want to know is where this dot moved for the blue graph. Well, let's see what happens. It moved over, it looks like 3 times, and then it moved up, it looks like maybe once here. So what you're going to do is you're going to describe what happened to the graph using the mathematical language. Okay, well this is pretty easy. It's a horizontal shift right, and it was shifted to the right 3 times. And we had a vertical shift up 1. And now you've described the transformation. Okay, let's do another one. So on this one, we still have the parent function, which is red, but now my graph is upside down. So not only was it shifted down and to the left, but it was also reflected over this x-axis. So there's actually 3 things we need to notate here. So let's go ahead and write the reflection. So we say reflection over x-axis. Then the shift to the 1, 2, 3, 4. Looks like it's shifted to the left 4. So we say horizontal shift left 4. And a vertical shift down 3. So vertical shift down 3. And you have described the transformation from the red graph to the blue graph. Alright, last example. So on this graph, it doesn't look like we shifted anywhere. Because if I was to draw a dot here, the graph is in the same place. But what I can see is that my red graph, the graph I started with, seemed to get smaller to create my blue graph. Now, hopefully you remember what I said about the rubber bands. Remember I said that when you pull on the rubber bands, they become smaller here? So since the blue graph is more narrow, I know that a vertical stretch occurred. So we would write vertical stretch. Now the only thing I can't tell from a graph is how much of a vertical stretch it was. So for now, you guys will just be required to recognize whether it's a vertical stretch or a vertical shrink. This concludes the lesson, so please remember that you can always stop and rewind the video and make sure you have taken notes while watching this.